Okay, hello everyone. So, yeah, last talk of the day. Did it went well so far? Was great? Nice. This one is better. Okay, so just before going to the great community event, I would like to talk about a brand new feature in API platform. Antoine told you a bit during his keynote, but we're going to dig a bit more about what is that, how does it work, and yeah, this kind of stuff. But before, let me introduce myself, something like that. My name is Mathias Arlot. I'm a French PHP developer, as you might have heard yet, and it will go worse and worse, from Lyon. I co-founded the Backslash company, as she said, the company you have on the lanyard, with Robin Chalas, which is a core team member. We do plenty of expertise, architecture studies, lead development, trainings about Symfony. So if you need help whatsoever, feel free to contact me. I'm also a member of the Symfony core team, and I contribute a lot to PHP, API platform, Symfony, and this kind of ecosystem, right? Okay, so before, I want to begin with a little story, okay? So make yourself comfortable and let me or let Papa Beaver tell you a little story. Right, so if you ever went through the API platform documentation, you might have noticed something. This is about books. Books are everywhere. You deal with books. So let's not break that habit, okay? So once upon a time in a bookstore, please, a guy who wants to prepare himself for the Symfony certification goes to the desks and asks for every book related to Symfony, right? The bookseller, at first a bit surprised, say, sure. And then he goes around the bookstore looking for any Symfony-related book. And in the meantime, the developer goes and sits on the bench and just wait for the bookseller to return. And as you can see, it seems to take a bit of time. I mean, plenty of time. And just before the developer decides to leave, the bookseller returns and gives him hundreds and hundreds of books, okay? Because yes, Symfony is popular, yeah. So now the developer just have to read all the books and try to be certified. Okay, then a few years later, a brand new version of Symfony has been released, which means that a brand new certification is available. That's why our developer, who loves to be certified, returns to the bookstore and asks for, once again, for any Symfony-related book. And like before, and not surprised anymore, the bookseller says sure and goes around the bookstore looking for any Symfony-related book. In the meantime, of course, the developer waits, and as before, it takes time, plenty of time. But this time, it seems to take several days, and even several nights. And this is even worse. Actually, our developer could have waited forever. Indeed, this time, this was too much book for the bookseller. He was not able to handle it, and he literally got crushed under the books. I have a sad news for you. Yeah, Mr. Bookman died under the pile of books. This time, this was just too heavy for him to handle them. Okay, so it is a story, it's cool, but you will understand later why, it is a metaphoric story, of course. Okay, so let's go back to our well-known development world. I want to talk about, I want to say some words about JSON, okay? So, who knows JSON? Yeah, just to keep you awake. I know you know that. So, the JSON stands for JavaScript Object Notation. And it has started as a lightweight way to represent data in JavaScript. But it is so simple and human readable that it has become the default format for APIs, for configuration files, for databases, even for logs, and even for browser extensions. This means that even if you are not aware of it, you have plenty of JSON file in your computer or in your smartphone, of course. Okay, so you can think of JSON as the lingua franca of data. It is basically how machines agree to talk to each other. When computer exchanges data, there are many chances that they are talking with JSON. And if you are developers, I'm sure that when I say API, you instantly think of JSON payloads, JSON responses, and so on. This is why in the API world, the JSON is king. Okay? And as PHP developers, what can we expect to find at the very core of the PHP API world? I give you a hint. Its name ends with platform. You are at the conference of its platform. Any guess? Yes, it's API platform. Surprise. So you might know a lot about API platform, and you might know a bit, and you definitely will learn a lot during this amazing conference. But for the ones who are still not sure about, what is API platform? What am I doing here? In short, API platform, it's a PHP framework used to build APIs efficiently. And it automates CRUD, endpoints for you, handles for you serialization, pagination, validation, and documentation out of the box. This means that when you are using API platform, you're just going to write business code, and you won't write boilerplate code because API platform handles it for you. Okay, so API platform, the core of the PHP API world. But I have another question for you. According to you, what is at the core of API platform when it comes to serialization? Any guess? Tout à fait, exactly. The serializer component of Symfony, right? So, the serializer component of Symfony, its role is to convert objects to and from formats such as JSON, XML, CSV, whatsoever. And one of its strengths, it allows you to configure how the data will be serialized in a really flexible and simple way. Okay, so let's talk a bit about API platform. Let's say that we want to do a request to get all shoes of our API platform application. So in the first time, API platform will retrieve somehow the shoes. And then it will give these shoes to the serializer component, which will do its magic, okay, and convert the shoes to the JSON representation of the shoes. And finally, API platform retrieve the JSON, and put it in a beautiful response and give it back to the client. Don't worry, we're going to talk about the serializer magic a bit later. But sometimes, because there are too many objects or maybe too many shoes, the serializer is, let's say, a bit tired, right? Like the Mr. Bookman was before. So let's dig why. But before, because this is the end of the day, let's play a little game together. Okay, ready? So, here are 4 words, and I want you to remember these words. Then I'm gonna hide them, and I want you to give them back to me. Okay, simple. So, please read the word, and 3, 2, 1. Okay, I'm listening. What were the words? Cat, nice, pizza, sun, and bike. It's way too easy for you. Perfect, indeed, it was cat, pizza, sun, and bike. Let's make it a bit harder. Ready? Now we have 10 words. No, it's doable. So we have 3. Elephant, coffee, mountain, laptop, it's getting long, banana, train, glass, chair, and music. So I'm going to drink a bit of water, and yeah, it's your turn now. So you. Okay? 3, 2, 1. Okay, let's go. I'm listening. Yeah. So, tree, elephant, coffee, mountain, laptop, banana, train, glass, chair, and music. You're so, yeah, okay. Congrats. I'm really impressed, to be honest. To be honest, without my notes, I wouldn't be able to, give of all of these words back. Anyway, for most of people, it's way harder and slower to give these words back. Okay, for the one who have succeeded, I have a last level for you. I hope you are awake. Ready? Okay. I think this time there is no offense, but yeah, too much stuff to keep in mind. So, together we have faced something that we can call the out-of-memory issue. Okay? The out-of-memory issue basically means that you do not have enough space in memory for all the data you want to put in. You have a too small brain. Sorry. Of course, this out-of-memory issue is not limited to humans' brain. Computers, softwares, programs, this kind of stuff are also affected. Okay? Okay, so now that we know what the out-of-memory issue is, let's see what happened under the hood when something is serialized using the Symfony serializer component. So, if you ever went through the Symfony documentation, you might have seen this schema, which describes, what's the workflow when a data is serialized. So, the serialization can be decomposed in two main parts: normalization and the encoding. First, the normalization takes care of converting the initial data to its normal form. Okay, what is normal form? Okay, in other words, it transforms the data so that it has the shape and the content of what we want in the final string, the JSON, for instance. And then comes the encoding part, and during this part, Symfony will take the array, okay, and encode it as JSON string. So the normalized data, for that, Symfony uses an array because it is a simple and a flexible data structure. Of course, the deserialization is the exact opposite. You take the JSON string, you decode it in order to get the normalized data, and then you denormalize it so that you get the initial data structure. Okay, so with that in mind, let's say that we want to serialize a huge amount of objects. After the normalization, all the objects will be contained in a single array, which is the normalized data. This means that we're going to have an insane array in memory. And just like it was with our human brain, even if you were impressive, it will be way more complicated and slower to process the data. And in the meantime, our client waits on his bench to get a response to his request. Okay, let's go back to our little story. Our Symfony developer told his friend that they can be certified of anything, any topic, if they read all books about this topic. So him and his friends came all together at the bookstore to ask for books. Sadly, the twin brother of Mr. Bookman, who has replaced him, of course, knows what to expect. Indeed, with all these concurrent requests, PHP at some point won't be able to reserve enough memory, and therefore, boom, out-of-memory issue. Okay, so do you remember the minigame we played before? It was a minigame about memory, so I hope you remember it. So, there is a simple way to solve this out-of-memory issue we have faced earlier, which is taking notes. In fact, when you read or hear a word, you can take a piece of paper, write the word down, then put the piece of paper, on your left, and free out some space in your memory. And then when you're going to need to list all these words once again, you just have to take the pile of papers and read the words one by one. And then, do you remember Mr. Bookman and all of his books? Once again, there is a simple and intuitive way to solve that out-of-memory issue. And the idea is to bring books chunk by chunks. You know, 1 by 1, 2 by 2, 5 by 5, whatever. And in that way, there won't be any weight issue. And these techniques, in the computer science world, are called, you guessed it, streaming. And in the Symfony world, there is a component created to stream JSON, which is the JSON streamer component. So, the JSON streamer component works in a very simple way. It consists of going through the data and write the JSON, the final JSON, small parts by small parts, bits by bits. And the JSON streamer is able doing so without any normalization step. Therefore, without putting all the data in one big array that's gonna explode at some point, for sure. To illustrate all of this, the JSON streamer component can handle a pile of book by taking one book after the other, encoding it as JSON into an output stream until all books have been properly serialized. Okay. So, some of you can ask themselves, what the magic behind that? How is this possible to do streaming, to do not do any normalization? How is it possible? You're curious, and this is great. And you will see that the trick is quite simple, in fact. Indeed, the trick lies in the fact that it is possible to guess the shape of JSON in advance using the metadata of a given PHP data structure. And thanks to another component, which is the type info component, Symfony is able to retrieve very precise information of the PHP data structure. For example, here, Symfony will know for sure that a book class has a string, a title property, which is a string, a rate property, which is an integer, and an in-stock property, which is a Boolean. Of course, this is a very simplified example. We could have read it using reflection only, but the type info component can read much advanced stuff, such as advanced PHP doc, templating, generics, and this kind of stuff. Then, the JSON streamer can use that metadata gave by the type info component and infer what the JSON shape will be. For example, here, the JSON streamer will know for sure that any book in the application, when it is serialized in JSON, will look like that. It's going to be an associative array, okay, with a title key associated to any JSON string, a rate key associated to any JSON integer, and an in-stock key associated to either the true value or the false value. In other words, this means that the JSON streamer will be sure that any book in our application in JSON will look like this. It will begin with a curly bracket, then have the title string, then a colon, then any JSON string, then a comma, and so on and so on and so on. You understood me. And this also means that the JSON streamer will be sure that a collection of books will look like this. Okay? It will begin with a bracket, and then it's gonna iterate over each book, and if it's not the first one, it will print a comma, then print the shape we've seen before, and do it for all of books, and end with a closing bracket. So, thanks to the metadata, we are able to guess a lot of stuff in advance. And this means that we can, if we want to, create a simple PHP function that takes a collection of books, for instance, and encode it part by part into a string by yielding, string parts and string parts and string parts. And this is exactly what the JSON streamer does. On the screen, you can see a PHP function responsible to encode a list of books. We can call it the book list encoder. Okay, there are several things interesting here. First, it's a bit cryptic. Second, this function does not do much. It has a try catch, do a little for each, call two JSON encode, have a ternary operator, and that's it. It's a simple PHP function, really simple, even if it's hard to read, because this is generated code. First, second, third, thanks to the for each, as we can see, only one book will be loaded in memory at any time. This allows us to serialize a collection no matter the size, and we're going to have a constant memory usage. And this is an interesting trick. Finally, we can note that only the parts related to a given book data are dynamic. The other parts are computed in advance, right? And printed as PHP code or raw string. So yeah, a lot of calculation has been done earlier and dumped as raw string. And this is one of the things that makes this component really fast, because most of the calculation has been compiled and dumped. But this is not the only thing that makes this component really fast. The other thing, and the main thing, is its workflow. So, when you use the JSON streamer component to encode a book, the JSON streamer will firstly check if there is already a book-related encoder, okay? The PHP file we have seen just earlier. If there is none, it will compute the book shape thanks to the type info component, infer the JSON shape, generate the encoder, and store it somewhere. And finally, it will use this encoder, which is the same as calling a simple PHP function that does not do much, And finally, it's gonna serialize the book. But then, for all of other books, because the related encoder has already been generated, the component will only need to call it, okay? Therefore, this comes to the same as only calling a simple PHP function that does not do much. Therefore, even if the generation is quite slow, like the normalization is currently in the Symfony serializer, it is only done once and can even be done, and is done, during the cache warm-up time. And this means that most of the time, the serialization is ultra fast because this is just calling a simple PHP function. Okay, it's fast, it's fast, it's fast. I want to see number. Okay, number. Let's look at some numbers. Here are some benchmarks, little benchmark of a serialization of 10,000 books with the cache warmed. So we have on the left the serializer and on the right the JSON streamer. So as you can see, the serializer takes 204 milliseconds, while the JSON streamer takes something half less, something like that. So this is great, this is nice. And what about memory? We talked a lot about memory. So when we serialize the same 10,000 books, the serializer needs 16 megabytes to serialize them, while the JSON streamer only needs 8. And of course, the more book we got, the greater the gap will be. I mean, if we wanted to serialize, let's say, 20,000 books, I'm sure that the serializer will need 32 megabytes of data. And the JSON streamer will stay at 8, because it's linear, constant. Okay, so I'm sure you're like that now. I'm still. So let's see how to leverage it. First, I have to tell, it's a well-known fact, performance comes with trade-offs, okay? And for the JSON streamer, the trade-off is to use a non-final class with public properties, without constructor, and without getters and setters. In the future, it might be possible to use constructors and getters and setters, but still, it's better, I think, to use a plain old PHP object, which is not an issue. If you have seen the talk of Antoine, he talked a bit about the object mapper, and you can map your entities with such classes. We're going to talk a bit about that data. Anyway, we need a plain old PHP object. And then you just have to write something like that. So you inject the stream writer service, then you find a way to retrieve the books in some way, and you define the type of what you want to serialize. In this case, a list of books. And you give that to the service and ask him to write a stream with the books and the type, and you get back in $JSON an iterable of string, okay? Something you can iterate on, and it gives you a string. And if you want to have a stream response, to stream a response with that iterable of string, it's quite simple with Symfony. You just have to put it in a stream response of the HTTP Foundation component, and voila. You can stream gigabytes of books if you want to, using that way. So it's simple. But, we are at the API Platform conference, so let's talk a bit more about API Platform. So, what if we replace the core of API platform when it comes with serialization that used to be the serializer, but with the JSON streamer? This is what we tried with Antoine the last month. But directly, we have an issue. Indeed, with the Hydra format, the JSON LD format, API platform adds some metadata to the JSON, such as the identifier, the type, the context, this kind of stuff, this kind of cool stuff, because thanks to that, you're going to get an hypermedia API. This is what we want, this is what we love. But if you remember correctly, we've seen that the JSON streamer component infer the JSON shape based on the properties of the book. This means that as API platform users, we're going to have to add these properties to our API resources. So, for instance, an array property which is virtual with a stream name @id, with a value that will be computed dynamically with a value transformer. We're going to talk a bit about value transformer later on. A type property with a stream name @type with the value book, and so on and so on. We, of course, don't want that. This is boilerplate code, and we love API platform because we do not have any boilerplate code, or just a bit. So, yeah, we don't want that. Hopefully, the JSON streamer component offers you some extension points. And one of them is the property metadata loader. And indeed, the property metadata loaders are the one responsible for computing the informations about properties of given objects. And this information can be the encoded name, the encoded type, and how you transform the value during the encoding. And there are some native that are able to read types using reflection and read PHP attributes for configuration, whatsoever. We don't care. What we care is, like, as usual in Symfony, you can define your own service, your own property metadata loader, and so that you are able to extend or replace the behavior when it comes to, computing the shape of an object. And API platform took advantage of it. As you can see here, okay, it's not too small. It has defined a custom property metadata loader that checks if an object is a resource. If it's not, okay, we stop that. We stop there. And if it is, it's going to add dynamically the property metadata, which are virtual because all of the value are computed thanks to value transformers. Anyway, we're going to talk a bit about later. And voila. Little parenthesis about value transformers because you might need to use some at some point, and it's an interesting concept. Value transformers are services or callables that takes property value as input and can do anything they want to return another value. For example, here we have a URL transformer that takes a value, can be an ID, I guess, and then convert that value to an URL based on that, using the URL generator service of Symfony. But be careful, value transformers are executed at runtime. I mean, during the actual serialization. Therefore, if they are slow, the whole serialization will be slow. And this is exactly the same as normalizer currently in the Symfony serializer. This leads me to say please don't call your database in normalizers and in value transformers. Don't call APIs either, don't do this kind of stuff. Otherwise, you're going to get a slow serialization. And I've seen that plenty of times. So don't do that if you can, please. Right. Okay, so thanks to that, our resource can still be this one, the one we know, okay? And with just only one line of code, JSON stream : through, you get a massive performance improvement. Because it's gonna use under the hood the JSON streamer component instead of the serializer component. Antoine told a bit about that. Yeah, be careful. With streaming, groups won't work anymore. This is a known limitation of the JSON streamer component. It does not support groups. And I won't dig about it into that talk because I do not have enough time. But it will never support group because we do think that this is kind of a bad design. You get an exponential complexity, a cardinality. And we have better ways to achieve the very same thing. So, hopefully there is a solution for this, and we can take advantage of the object mapper. Indeed, the object mapper, Antoine told you a bit, helps you to convert objects to other objects. For example, here I can convert a book entity to a book resource by ignoring the ID, mapping the title, renaming the price, I don't know, transforming the value of a stock, and so on. You can do plenty of stuff. But therefore, by using it and its great integration to API platform, you're going to be able to decline any data in many API resources. For example, we can decline the book entity in several book resources with the shape we want. So by doing so, by groups, we achieved the very same thing, okay, but in a much cleaner, clearer, and better way. And it's going to work with the JSON streamer as well. Okay, so let's do some benchmarks again, but this time with API platform. So we're going to consume an API platform API and call an endpoint that returns 10,000 books with the JSON stream and without the JSON stream. First, let's look at the time to first byte, which basically means when do I get a response, any byte, even if it's a partial response. This is not a surprise. With streaming, we get a partial response way quicker. And this is logical because without streaming, we're going to have to wait for the whole response and the whole JSON to, receive any byte. And having a small time to first byte is great because the client, using JavaScript or whatever, can already keep the user informed that something is happening. I'm getting something. Maybe I'm gonna, show a progress bar or whatsoever. So for the user experience, having a little time to first byte is great. Then the speed. As you can see, in the same time frame with JSON stream through, we are able to send something like 2 times much more data. And indeed, this makes sense because if you remember the encoders, a lot of stuff has been already done during the cache warm-up. And plus, even if the server has to process all items, in both cases, the streaming reduces the memory pressure and prevents some memory swapping and this kind of stuff. So it's easier for the server to have a low memory usage. And finally, it allows to overlap CPU time with network time. I mean, when I serialize the book number 50, the book 1 is already on the network. So it reduces as well the pressure on the server, and it makes it faster, of course. Yeah. Then, last but not least, hard to say, the perceived speed, which is, to me, as important as speed, if not more important. Because it improves a lot the user experience, and this is what we want. So let's imagine we want to display, the number of items of a list of books, for example. When using API platform, we just have to read the total items value. Without streaming, we are used to do that. Okay, we fetch the URL, we wait for the response, and then we read the JSON in the response, and then we read the total items from the JSON, from the response, from the URL. Okay, but now we are able to leverage streaming. So we can write a bit more complicated code, right? Don't try to really understand. It works. I can send it to you if you want to. It's a bit more complicated because it parses an unfinished JSON. And we have some libraries, some JavaScript packages that helps you doing so. So here I return parse JSON string that takes a stream and look for a selector. And as soon as it has found the selector, it returns it. I mean, with that code, with that function, we're gonna read the stream, okay, fetch the URL, read the stream, and stop as soon as we got the data we need. The total items, for instance, without taking care of the rest. So this means that we're going to read context, ID, type, total items, and stop. And so most of the JSON, the members, just going to be ignored. So it's really fast. and I have to be fast. So the results are impressive. With 10,000 books, it's 6 times faster, and of course the gap will increase with the number of books. This is logical. And we can go even further. I had to talk about the Edge Side API architecture, ESA, but yeah, I ran out of time, so we're going to talk a bit, but it's just a bit. So let's say we want to follow the Edge Side API architecture created by Kevin Douglas a while ago. I really encourage you, because I do not have time to talk about that, to see his related talk, because it is really powerful and it helps you design your APIs in a very sensible and performance way, leveraging modern HTTP techniques. So, this architecture, at some point, encourages you having resources as small, as atomic as possible. This means for a list of books, each member going to be an IRI. It won't be nested object, according to this architecture. So we can write once again a code that's going to read the stream and then find all the IRIs using the members wildcard here and iterate over IRIs and fetch the data using another API call and display the data, the books, as soon as the second API call is ready. Okay? By doing so, with that approach, you're going to get the first book incredibly quickly. And same for the second one. And same for any book that the second API call ended first, until you got, all the books. Okay, so long story short, with few lines of code for you at least, and modern HTTP techniques, you're going to be able to deliver massive JSON collection smoothly in terms of performances and memory. So if you need for speed, not the movie, but if you need for speed and deal with a lot of data, just go for it, okay? Otherwise, it's better to stick with the actual implementation as it is battle-tested and more flexible and easier for you to use. And yeah. So the JSON streamer component is available in Symfony starting from 7.3 as an experimental component, and its iteration in API platform has been released, let's say, 1 hour ago in the 4.2 version of API platform. So if you are curious and looking for performance, please give it a try and let me know. Okay, so it has been a lot of information. I'm sure you want to be like that right now. And I even only talk about serialization. I did not talk about deserialization, so I have plenty to say. But still, it was a dense talk, so in my opinion, you have deserved to go grab a drink at the community event to process this information. And of course, feel free to catch me up at any time if you have any question. I will be happy to answer it. Thank you.